Alright, the next example I want to do is question number 29 from the book, which is integral of 1 over 4 plus 4x squared plus x to the 4, which can be written as 1 over x to the 4th plus 4x squared plus 4, right? So do you know that this can be written as 1 over x squared plus 2 whole square and then dx, right? So this is like x squared plus a squared format, right? Because you can write x squared plus root 2 square, that is like x squared plus a square, and then outside there is whole square. So set x equals to root 2 tangent theta, right? Because it is x squared plus a square format. So dx will be what? Root 2 times secant square theta times d theta, right? That's the derivative. Okay, so what do you write on this one then? This is written as, integral is written as 1 over x squared is 2 tangent square theta, right? And then plus 2 square there, and then the dx is basically root 2 times secant square theta d theta. Okay, so you can take the 2 out from the denominator. What do you get? You get integral 1 over 2 tangent square theta plus 1, right? And then there is a square, and then there is a root 2 times secant square theta d theta. See that? So let me pull that root 2 out. You got root 2, and then how about this one? You'll get 4 on the denominator, because you see that 2 square is 4. I am writing that 4. You get secant square theta d theta, right? Divide by, what is tangent square theta plus 1? That is secant square theta again. So it will be secant 4 theta. You see that 2 square is pulled outside. Okay, guys. So from that on, you get equals to root 2 over 4. Root 2 over 4. What is left is 1 over secant square theta d theta, because there is a secant square in the top. And the secant 4 theta is secant square theta times secant square. So one of them cancel out, right? That will be root 2 over 4 cosine square theta, right? D theta, because 1 over secant is cosine. So root 2 over 4, you have integral 1 plus cosine 2 theta, because to find out the integral of sine square and cosine square, you need to change into the the multiple angle formula. You see that? So what you get here, you can pull that out. You get root 2 over 8, right? And the integral of 1 plus cosine 2 theta d theta. Okay, so what is the integral of 1 is, let me write down root 2 over 8, and then integral of 1 is theta, right? Plus integral of cosine 2 theta is sine 2 theta over 2. Okay, and then plus c. See that? Now we need to plug in the value of theta. But by the way, let me write the formula for sine 2 theta. Root 2 over 8, and then theta plus 2 sine theta cosine theta. That's the formula of sine 2 theta over 2. Plus, you see that 2 and 2 cancel out. That 2 divided by 2 will go away. Okay, and also I need to find out what is theta and what is sine theta cosine theta, because our question was in terms of x, right? So we need to put our answer in terms of x as well, because we have x equals to root 2 tangent theta, right? So what is tangent theta then? Tangent theta equals to x over root 2, right? Which is the ratio of perpendicular and the base, right? The opposite over the base. So let us make the triangle. Let's say this is the reference angle theta. That's the base is root 2, and the perpendicular is x. So what will be that one then? That will be x squared plus 2. That is the under the root perpendicular square plus base square, right? That's what we're doing. So therefore, also from here you can write theta equals to what? Tangent inverse and then x over root 2. That's what you get. Okay, let's plug in that. Therefore, let's say that the question was I equals to, so you can write I equals to root 2 over 8. Theta is tangent inverse x over root 2. Okay, and then plus sine theta is perpendicular over the hypotenuse, that is x over root, oh, by the way, yes, so root, what do you get? X over root x square plus 2, that's what I get, right, times, and then what is the cosine theta? Cosine theta, this one is base over the hypotenuse, right? Root 2 over the hypotenuse is x square plus 2, okay, and then plus c. So if you multiply those two, you get what? Root 2 over 8, okay. This is tangent inverse x over root 2, right, and then plus this is like root 2 times x, okay, divided by what? You get x square plus 2 times x square plus 2, but root, that will be x square plus 2 plus c. That is the final answer. Okay guys, so this is how you do it. So I want to do one more example. This example would be question number 35. So question number 35, let's do that. 35, which is integral of x over under the root x square plus 6x plus 12, x square plus 6x plus 12, and then there is dx. Okay guys, so this problem, again as the last problem, we should write the bottom as the complete the square, right? So what I want to do is integral x over, you can write this as like x square plus 6x plus 9 plus 3, right? Why did I do that? Dx, because I know that x square plus 6x plus 9 is x plus 3 square. That is the reason, okay? So this is equals to integral x dx over under the root, you can write x plus 3 square plus 3. It is like x square plus a square here, right? You see that? This is like x square plus a square. But in place of x square, there is x plus 3 square. So, and so this can be written as like x plus 3 square plus root 3 square, right? So that is like, this is like x, this is like a, right? So what you can do in this case is set x plus 3 equals to root 3 tangent theta. Same process, only the difference is you got, instead of x, you got x plus 3. That's the only difference, okay? So what do you get there? Then the derivative will be dx will be what? Root 3 secant square theta d theta, right? That is the dx. So what do you get if I plug in that into the integral? Then integral will be, so what will be x plus 3 is root 3 tangent theta. So what will be just x? You subtract 3 from both sides, right? Because you get x equals to what? Root 3 tangent theta minus 3, right? That's what you get for the x, and dx will be that thing. So you can write this as root 3 tangent theta minus 3 from here, from that line, okay? And then what is d theta? D theta is root 3 dx is secant square theta d theta. That's what you get in the numerator. In the denominator, what do you get? X plus 3 is basically what? X plus 3 square is what? 3 tangent square theta. Tangent square theta plus 3. See that? That will be how much? So that will be root 3 tangent theta minus 3, right, times root 3 secant square theta, and then what? D theta, divide by, if you take 3 out, what do you get? If you take 3 outside, tangent square theta plus 1, right? Tangent square theta plus 1. So if you simplify this, you will get, let me pull that root 3 out, okay? You get root 3 and then integral root 3 tangent theta minus 3, right? And then times secant square theta d theta. You see that? Divide by, you can take root 3 out. So let me take root 3 out from the denominator. What is left is tangent square theta plus 1. What is that? That is secant square theta, right? But root under secant square theta is just secant theta. Okay? Now you can cancel one of those. So how do you cancel that? Is secant theta and one of the secant from secant square will cancel out. So what is left is that will also cancel out. So basically this is what is left, root 3 tangent theta minus 3, you see that, and then times secant theta d theta. Okay, now what I want to do is I want to distribute that secant theta to both of these integral, and I want to split the integral as well, tangent theta times secant theta d theta minus 3 integral secant theta d theta. So I broke that two integral. First I distributed the secant theta to both, and then I broke the integral to two integrals. Okay, now let me continue from there. So let me move this. So do you get there? What is the integral of tangent theta secant theta, or what is the integral of secant theta times tangent theta? Because we know the derivative of secant theta is secant theta tangent theta. So the integral of secant theta tangent theta is secant theta only. So you can write root 3, okay, and then secant theta minus, what is the minus 3? What is the integral of secant theta? It is natural log, right? Natural log of secant theta plus tangent theta. That is by the formula, and then plus c. Okay, now I want to write in terms of x. All right, so let me do from here. You got tangent theta is equals to, you got tangent theta is, because from here, right, from here you got tangent theta equals to what, x plus 3 over root 3, right, which is perpendicular over base, right? Let me make the triangle and then see which one is what. So that is perpendicular is x plus 3, base is root 3. So what should be the hypotenuse? That will be like, that will be root under x plus 3 square plus 3. That's the hypotenuse of it. Okay, now we need to plug in all those ratios using x. So root 3. What is secant theta? Secant theta is hypotenuse over the base. So you will get that over that. That is basically what? Root under x plus 3 square plus 3 over root 3. Did you see that? Basically the, oops, you don't need the whole thing, just a little bit. So basically you can cancel that, root 3 and root 3, right? And then minus 3 natural log of, what is secant theta? Secant theta is again root x plus 3 square plus 3 over root 3 plus tangent theta is what? Tangent theta is that x plus 3 over 3, p over the perpendicular over the base, right? So that will be x plus 3 over root 3 plus c. But you know what, I want to write like, because you know that x plus 3 square plus 3 is x square plus 6x plus 12, right? So I'm writing in that form. Okay, what I'm going here is root under x square plus 6x plus 12 is that x plus 3 square plus 3 minus 3 natural log of, how much is that? That is under the root x square plus 6x plus 12 over root 3. Okay, and then plus, let me write on that, and then plus x plus 3 over also root 3. If you want to, you can make the same so if you want to, you can write the same denominator there. Okay, and then integral of that, and then plus c. That is the final answer. Okay guys, so this is the end of 8.4, section 8.4. all right.